Howdy Huskies and welcome to Unit 8. This is a very important unit for this year and the coming year. So this is one you really want to have your A game on. So let's go ahead and get started. Today we're going to talk about Pythagorean theorem and its converse. It's obviously a very, very important theorem. It's been verified by almost every society around the entire globe, as well as has been proved many, many, many different ways. So it's actually a pretty cool one. So we awfully know that obviously it says if a triangle is a right triangle, we have to start with that, then here's the magic, a squared plus b squared is equal to c squared. So if we draw our good old right triangle here, including our 90-degree box, your hypo is going to be the longest side. It's going to be opposite that 90-degree box. It has to be the C. But then the other two could be A or B. A or B. Now, if it was up to me, ladies and gents, I would go ahead and since C has to be the largest, I'd make A the smallest. It doesn't matter, as we just mentioned, but it just does make it a little bit easier. So we'll go ahead and rewrite it as this. Cool? So, ladies and gentlemen, boys and girls, let's go ahead and reduce some radical reviews. We're going to be doing a lot of square roots in this unit. So this is an easy one. It's 11 times 11, and those are going to be a pair. So they're going to leave us one number. And so technically, this is going to be plus or minus 11. Now, we're going to be all about the principal root, which means we're only going to care about the positive. All right, let's look at the next one. So this one doesn't have a perfect square, so we're going to go ahead and say, all right, this is going to be 4 times 13. The 4 is going to be 2 and 2. When I break something down, I like to cross it out, then circle my pair that's going to leave in one number, put a box around my single. So this is going to be 2 root 13. And again, you're always looking for those perfect squares. So yes, you could do 15 and 3, but let's go ahead and do 9 and 5, since 9 is that perfect square that we know. So the 3 is going to leave us one number, and then we have, once again, a single 5 that will stay inside the radical. Alrighty. I want you to hit pause and try the next two. Welcome back. So this is going to be 36 and 2. This will be 6 and 6. There's my pair. So this will be 6 root 2. Now, you might have not done 36. You would have done 9 and 8. We should get the same answer when we're all said and done. So just to make a point, let's take a look at 9 and 8. So this is 9 and 8, 4 and 2, 3 and 3, 2 and 2. So I have a pair of 2s that are going to leave. I have a pair of 3s that are going to leave. And we're going to multiply those together. And then this single 2 is going to left inside. So then again, we get 6 root 2. So I wasn't lying. We got the same answer. Alrighty, so this will be 4 and 10. And 10 breaks down to 2 and 5, but since those are both singles, this is going to go ahead and turn into 2 root 10. So you're going to multiply those singles together. So a little review of Algebra 1 there for us. So let's go ahead and jump in. So the first thing I'm going to do is label. So when I label, I locate my 90-degree box, and I go to the opposite side. Boom. So this is going to be my hypo, which of course is going to be my C. Then I look for the smallest. So in this case, the smallest is going to be this 4, and so I like to call that my A, but again, it doesn't matter. And so this is going to be B. So if we do A squared plus B squared equals C squared, this will be 4 squared plus 6 squared is equal to X squared. So 16 plus 36 is equal to X squared. So we're going to go ahead and get 52. Now, again, this right here is x squared, so we're not done yet. We have to take the square root of both sides. So if I break down 52, I'll go ahead and do so over here. I'm going to go ahead and notice that this is going to be 4 and 13 because we just did it right up there. 2 and 2 is my pair, so my answer here is going to be 2 root 13. Now, that is a decimal, so if you might be mindful of your direction, so if they say you can leave it in decimals, then we would do 2 root 13 in our calculator, and it'd be 7.2. Now, again, that's 7.21. Circle that as well. This is definitely larger than 6 and 4. Okay, so you can look at these and use some common sense to help you say, hey, is my answer making sense? All right. So in our next one, we given the hypo. So my hypo, again, in this case, is going to be the longest side, which is C or 13. So I'm just going to go A and B. Now, I'm going to notice that A is going to be larger than B, and that's okay, because remember, it doesn't matter. So this is A squared plus B squared is equal to C squared, or X squared plus 5 squared is equal to 13 squared. So X squared plus 25 is equal to 169. Now, before you do any square roots, let's get that X squared by itself, meaning this has got to go to the other side. So X squared is equal to 144. Now we'll go ahead and take the square root of both sides, and we're going to get X is equal to 12. Why isn't it negative 12? Because, again, it's the side of a triangle. You can't have a negative distance, so that's why it's just going to be 12. All right, why don't you try 8 and then hit play. Welcome back. So the 15 is going to be my C, because it's also opposite to 90 degrees. So y squared plus 7 squared is equal to 15 squared. So y squared plus 49 is equal to 225. So then we get y squared is equal to 176. Got to take the square root of both sides. And so this is going to become 16 and 11. And then that's 4 and 4. Since I have a pair, I'm going to stop. So 4 root 11. Now, what happens if you break down the 4s? You're just going to get 2 pairs of 2s that you'll multiply together. It's going to be okay. All righty. Number 9, a little saucy because we got some algebra. So this right here is going to be my C, and that's okay. And now because this is X and this is X plus 1, I'm going to go ahead and call this X A, and this one will be B. So A squared plus B squared is equal to C squared. So I'm going to get X squared and then X plus 1 squared. Now be careful, notice how I'm making it X plus 1 parentheses squared, that's important, is equal to 5 squared. So this is going to become X plus 1 times X plus 1, and then we're going to have to do a little FOIL, a little first, outside, inside, last, or double distributive. So X squared plus X plus 1 is going to give X squared plus 2X plus 1. And then this obviously will give us an X squared. And then this obviously will give us a 25. So when we put these two together, we're going to go ahead and get, because I have 2X squareds, 2X squared plus 2X minus 24 is equal to 0. I got to bring this 25 over, because when you have an X squared and an X, you have to set it equal to 0, and that's how you're going to solve it. Alrighty. So because we have a GCF is a greatest common factor, or something you can divide out of everything, we're going to divide both sides by that GCF of 2. And that's going to make our math a little bit easier. Well, our answer will be the same. Cool? Alrighty, so then we say, alrighty, most of us remember making the X. So what two numbers? Now you can factor any different way, but this is how we do it at Reno High. What two numbers multiply to a negative 12 and add to a positive 1? And that will be 4 and a negative 3. So I'm going to get X plus 4. X minus 3 is equal to 0. And then take each one individually and set them equal to 0. So this will be X equals negative 4. We should have a red flag jumping up on that one. We'll get to that in a moment. So X minus 3 is equal to 0, or X equals 3. So our only answer in this case is going to be 3. The reason is if you take this negative right here and you plug it back in, you're going to get a negative answer, and you can't have a negative side difference. So this is what we call an extraneous solution. For those going on to Algebra 2 Honors, we do a lot of extraneous solutions next year, so get used to seeing those. So this is the Pythagorean theorem. Okay, obviously we have some basic ones. These ones you should have been able to do before you walked in today. This one is definitely our formal geometry level. So make sure you are prepared to being solved by those. And if you don't, or if you have questions, make sure you show up and talk to your teacher and get a little extra help. Okay? So what is the converse? The converse says that if a squared plus b squared equals c squared, then it is a right triangle. So we can use this to decide what kind of triangles we have. And we're going to talk about that in just a moment. So notice right here, there's no 90-degree box. There's no perpendicular mark. So what you're going to have to do is say, alrighty, we're going to have to see that this a squared plus b squared equals, a squared plus b squared equals c squared. Now this c still has to be the largest, okay? So over here, this 12 looks like the largest, so it's still going to be my c. So I like to think of it as x squared, and then I go line c squared. Because I'm not sure if it's equal yet, I want to make that case. So that's why I say it's not equal. I do this little T-chart. If you do, it's nothing wrong with that. So I plug in my numbers, and so 25 plus 100 is 125, but this is 144. So this is going to be not a right triangle. And since that's what our directions say, this is actually our answer. All right, let's look at the next one. So this right here is going to be my c because it's the largest. So I'm going to go a squared plus b squared line c squared. So 7 squared plus 8 squared. So I'm going to get 49 plus 64. And that's going to give me 113. And does that equal 13 squared, which is 165? Once again, no. So this is not a right triangle. And that's our answer. Alrighty. So we look at this one, we're like, not sure what the largest number is. So let's get our calculator back out. Let's turn it on and let's find out what 4 root 2 is. So 4 root 2 is 5.65 blah, blah, blah. Okay? Which just means, and the reason why we do that is we now know that this 8 is going to be our c. So a squared plus b squared line c squared. Alrighty. So 4 root 2 squared plus 4 root 2 squared, 8 squared. Well, we know this is 64, so let's do that part. That's easy. So when you have a parenthesis squared, just like we did before, you're going to write it twice. So we'll do our outside. So 4 times 4 is obviously going to go ahead and give us 16. And then our insides, root 2 times root 2, is going to give us 4. Now we know something about the square root of 4. That's going to be 2. So this is really 16 times 2, which is 32. Well, that being the same thing, it must also be 32. So I get 64 is equal to 64. So our answer is that this is yes, it is a right triangle. Yay, right triangle. Alrighty, so now that we have the converse and the regular Pythagorean theorem set, we have some corollaries that go with them. And I'm not a fan of corollaries and trying to remember decimals, and so I just call it the acute Pythagorean theorem that says if a squared plus b squared is greater than c squared, sorry, I meant to say if, then triangle ABC is an acute triangle. So this is the important part right here. So a squared plus b squared is bigger. All right, so then the obtuse corollary, I'm sure you could guess, if a squared plus b squared is less than c squared, then triangle ABC is obtuse. So this is the one we have to remember right there. So it sums up to this. If a squared and b squared are bigger, okay, then it's acute. If c squared is greater, that's obtuse. And if they're equal, they're right. So again, that's the reason why I do this a squared plus b squared line c squared, so I don't have to change my signs, I can just look and say, which one's bigger? Let's roll with it. But the kicker, and let's go ahead and make a special note here, is that the C is always the largest side. Always, always, always. All righty. Now that we got that, let's go ahead and do some triangle inequality review, because it's important that we know what an actual triangle is. So there's two parts to this, okay? Is that the first part is that A plus B is greater than C, okay? So, or it is not a triangle, okay? Notice there's no squares. So we have to actually do A plus B is greater than C to make sure it actually works first, okay? So here's what we're going to do. I guess let me explain this. So if this right here, if this is 3 and this is 4 and then this is 12, this side is going to go way so much longer that it's actually not going to close, or it might look something like that. Or on the other side, it might not actually get all the way over there. Like this is like a 2. You with me? So just a heads up there. All right, so here's what you're going to do. This is going to be step 1. Is it a triangle? Okay, so this is it a triangle in the first place. Then, so step 1. Step 2 is then your A squared plus B squared line C squared. Okay, so let's do number 4. This is obviously going to be my C. So it's 5 plus 12 greater than 13. Because this is my triangle check. This is A plus B is greater than C. And since it's true, then it is a triangle. So now I'm going to go A squared plus B squared line C squared. And go 5 squared plus 12 squared is equal to 13 squared. So 25, 144. And this is going to be 169. And since 169 equals 169, so my answer here is this is a right triangle, because it's asking us what kind of triangles are they first. Alrighty, number 5. So this is obviously my C. So is 7 plus 14 greater than 16? Check, it is, because we're going to get 21 is greater than 16. So I'm going to go A squared, B squared, line C squared. So 7 squared plus 14 squared and 16 squared. So we're going to get 49, 196, I believe. Let me double check using my calculator. Yep, 256. And so this is going to be 245, and this is 256. Well, obviously, this one is larger. So since that was the C squared is larger, this is going to then be an obtuse triangle. That's our answer. Alrighty. So this is my C because that's the largest. So it's 12 plus 16 greater than 20. Yes, it is. So this is going to be A squared, B squared, line C squared. Hopefully you're getting the gist of this. So 12 squared, 16 squared, 20 squared. So 144, 256, 400. And so we're going to get, I believe this is going to be, yep, 400 equals 400. So this is going to be a right triangle. Cool. All right, sports fans. So then let's look at this next one. This looks like it's a tricky one because we're saying, wait, there's no C. So in this case, remember that you can be a equilateral triangle, right? Isn't that equilateral? All the sides are the same? Cool. So that means, remember, if it's an equilateral triangle, all of our triangle stuff never goes away. So equilateral means equiangular. So if it's equiangular, all these sides are the same. that means that all these are 60, right? So that means that we can go ahead and say that this is going to be an acute triangle right off the bat. So we don't actually have to do it using by our previous knowledge. All right, number 8 is tricky because you're going to want to jump right into it, but notice that 8 plus 12 is not greater than 20 because it's not greater than or equal to. It's not greater than. So this is not a triangle. So that is our answer, and so it's important to know that it's possible for it not to be a triangle. All right, you're on number 9. Give it a shot and then come back. Welcome. So hopefully you put that square root 170 into a calculator and you found out, hey, that's 13. Okay, so this is 13.01. So this technically is larger. Okay, so, and if I go 1 plus 13, that's greater than 13.03 because that's what we just saw right here. We'll say 04. Excuse me. Cool. So then we're going to go a squared, b squared, c squared. So 1 squared, 13 squared, and then root 170 squared. Now that 170 and that squared are just going to cancel it out. So this is just 170. So 1 plus 169. So 170 equals 170. So this is a right triangle. Booyah. Alrighty, and then the last one. Okay. So ladies and gents, this is a tough one because of all the radicals. This is our formal geometry level type example. Get that calculator. Find out what they are going to be. Okay, so if we go ahead and we do this first one, so 2 square root 5, that's 4.47. That kind of looks like the baby bear. And then 4 square root 5, that's 8.94, 8.94. All right, that looks like to be the C, the Papa Bear. But let's double check. 4 square root 3 is going to be 6.92. Okay, so we probably could have guessed it, but that's going to be our C. So we can clearly see that A plus B is greater than C because 4.47, 6.92 is definitely bigger, so we're good there. So let's find out what triangle it is. A squared plus B squared, line C squared. All righty. So I'm going to get 2 root 5 squared plus 4 root 3 squared, and then 4 root 5 squared. Why don't you guys hit pause one last time, try your radicals, see how you do, because the algebra could be tough and we want to make sure you're good. Hit pause. Welcome back. So there's going to be 2 root 5 times 2 root 5, which is 4 square root 25, which is 4 times 5, which is 20. And then this will be 4 root 3. 4 root 3 is going to give me 16 root 9, which is going to be 48. Yep. And then last but not least, 4 root 5. 4 root 5 is going to be 16 root 25, which is 80. All right, sports fans. So is 68 bigger than 80? Nope. So this is going to go ahead and be obtuse. Cool. All right, sports fans, that is your notes for today. Hopefully this has been helpful. We'll see you later. This is Mr. Naughton saying, keep doing some math. It's good for you.